Okay, hi. This is week 8 now, and since the previous week, what we are really doing is that every week we are now going to cover two aspects. One is basically the UML aspect. In the UML aspect, we'll just get a brief overview of certain types of diagrams, and the other part of the week will be dedicated towards learning some kind of system building skills. That is the overall idea. So in this week, what we are going to have a look at are state diagrams. So that is the first thing, and then in the next lectures, what we are going to look at is how to do some basic networking. So let us start. But before we go towards state diagrams, let us just get a recap of the overall picture that we are trying to cover, right? So what we are really trying to do is we are trying to figure out ways in which we can express a particular system's details, design details before the system is being built. And we had a discussion that these details can be categorized under two categories: structural and behavioral. The structural details, okay, to capture the structural details of the system, one aspect, okay, one type of structural detail can be covered using the class diagrams that we have covered in the previous week. And now in this week we are going to have a look at some way in which we can categorize certain type of behavioral aspect of a system. Okay, to do that we are going to use a state diagram, right? So what exactly are we trying to do now? Essentially, the class diagram talks about classes, right? It is going to tell you that in your system these are the different classes, and these are how they relate to each other. One could be the generalization of another, or there could be a case of aggregation or composition or a simple association. So all those things, all these details are provided to you by the class diagram. But once the system actually starts executing, classes are not really an entity which are seen in the at when the system starts executing. When the system executes, you have objects, right? These objects are essentially the instantiations of the classes that you have declared. So the state diagram is a diagram whose job is to show, or at least attempt to depict how exactly a particular object changes itself during the execution of your system. Okay, so this overall idea of showing the behavior of a system by showing how the objects uh, transform transform from one form to another, this is captured through a state diagram. So coming back to the whole concept of an object, let us say that if the class is human being, then we all are really the objects of that human class, right? And if we compare an object to us, what are the typical kind of moods that we could be in? Okay, we could be happy, we could be sad, we could be angry, relaxed, whatever it is, right? I mean, there are so many moods available out there. And does this mood actually affect our behavior? Well, yes, probably yes. So based on the different moods that we have, our behavior is different. So this is in some way an analogy to what the state diagram is trying to show, that you have an object in your system, and this object, based on the different states that it has, its behavior is probably different. And what exactly do we mean by the state of an object? So essentially, a state of an object is nothing more than just the collection of all the values that are there, for all its fields, right? So the possible number of values that can be there, right, will be the Cartesian product of the set of values of all the fields, right? So now you can understand it's a huge set, right? The number of possibilities that can be there, the number of possible values, or the number of possible states that a particular object can take, it could be in millions or even billions, right, depending on how many fields you have, and what are the possible values that each field can take. So you can understand that there are so many different possible states, right? But usually this is the case that not all the states may be valid. Okay, why? Because within the domain in which you are actually building your application, there may be certain restrictions, there may be certain constraints. So for example, if we talk about banks, let us say you have an object of type transaction. So this is trying to depict a typical banking transaction where money is sent from one account to some other account. So also assume that this transaction has fields like old balance and new balance and the transaction amount. So now you know that if the transaction amount is positive, that is it is a credit, then the old balance should be increased by the same amount as the transaction amount. Or if the transaction amount is negative, then it means it's a debit. So the old balance should be reduced by the transaction amount. So in any case, right, the new balance should be equal to old balance plus the transaction amount. The transaction amount could also be negative. So that the only valid state which from which this particular account can to which this particular account can move into is this particular state where the new balance is equal to old balance plus transaction amount. And all the other possibilities, of the fields having different types of values, that is actually invalid, because this is the constraint that the domain applies on the on this whole system, right? So this is the idea that even though the actual number of possible states could be a mind-boggling number, usually you have a much better handle on what states are actually valid and what states are not valid based on your understanding of the domain. So this is what is a state, right? So you understood that basically any particular object can transform itself into something else, right? So when I say something else, means that some of its fields, at least one of its field gets changed. So you say that the state of the object has changed, so it has now become a new state. Now, this transition from one state to another is also of importance, right? We call it transition straight away. So, transition represents a change in the state of an object. So, this particular state of the object could be changed due to multiple reasons. For example, it could be because, let us say, you're using this object to collect user input. So the user typed something on the screen and pressed enter, so now you have to assign that value straight away to the object. Or it could be because, let us say, some scheduled operation has now taken place. Scheduled operation as in something that was scheduled to happen at certain point of time. So at which point the object's values changes or something like that. Overall, whatever transition happens, right, it happens because of the occurrence of an event. Okay, this event could, as I said, could be something like clicking on a button, typing some text. So it could be user driven event, or it could even be things like a time driven event. So you can put an alarm, for example, in your system, and as soon as that alarm gets triggered, an event has occurred, right? So and something has to be done, some changes have to be made to the object. But overall, what we are really trying to say is that the state of an object sees a transition to another state on the occurrence of some event. So this is how we are trying to capture the behavior of that system, basically the behavior of that object in the system, and that is what a state diagram is going to do for you. So this is how it looks like. This is state A for object, this is state B for object. Then I draw an arrow. This arrow represents the transition from state A to state B, and whatever I write over it, okay, is the event. Because so essentially this is a way to depict diagrammatically that this particular object's state will change whenever such an event happens. So this is a way to represent something in a state diagram. This is very simple, but you have to understand that these are states, this is a transition, and this is an event. Now the whole concept of an event, by the way, it is not something that may be specific for an object, right? So an event could be something that happens in a completely different scenario. It could be something that needs to be caught, for example, or you need to uprise multiple objects in the system about a particular event. So I gave you an example, right, when we were having our previous lecture, that if I click on the unmute button in WebEx, it's an event, and this different threads in the system should be told that something like this has happened. So in addition, to summarize, there might be different objects in my system whose state may have to be changed because I clicked on unmute, right? So that is the idea, that an event is not something that might be associated with an object itself, right? It could be a system wide thing, and multiple objects may be affected by this particular event. So you can say that whenever a particular event occurs, a number of objects may or may not change. That is the idea. Then we can, and when we have this particular scenario, that there is a possibility that even though the event has occurred, but the object's state may not change. This is where we need some kind of conditional transition, right? That the event has occurred, but the state of the object will only change if a particular condition is true, right? So for example, let us say there is an object of type account in the system, and there is an event called request debit, right? So there is a debit request that has come for this particular account. So in this case, the event is more specific to this particular object, but it could be across the system as well. Anyhow, so let us say there is an object of type account, and for this particular object, an event has occurred. Okay, so there is a request for some debit which has come from the user. So now at this point of time, ideally it should really do whatever I just showed you in the previous slide, right? So a transaction object is created, and then the old balance is updated, and the new balance is slightly lower, or lower, I should not say slightly lower. The new balance is lower than the older balance. But all these things can only happen if the transaction amount is proper, as in, you cannot ask for the debit of, let us say, 1000 rupees if if the balance in your bank account is only 500 rupees, right? So in such a case, even though an event has occurred, a debit request has come, the object might not change its state because of certain reasons. Okay, and again, these reasons again come from the domain. You are not the one who decide upon it. It is the domain which enforces these things, that for a particular event you must check that this condition is true, and only then should the object change its state, right? To represent such a scenario, you can use what is known as a guard condition. Okay, so a guard condition can also be specified over a transition, right after the event, in square brackets. Okay, so if you provide the condition in a square bracket, it essentially means that there will be a transition. This transition will only go through if this event occurs, and at that point of time this condition is also true. Another, just one more aspect of state diagram is the concept of an effect. So what happens is, whenever a state transition happens in the real world, the domain might have a description for this, right? So for instance, if the debit request was accepted, thus if the state of the account object changed, you can say that there is a description for this, right? This particular transition. The description could be, account debited with amount xyz, right? So this could be a description of what just happened, right? It could be a description of the transition that just happened. So if you also want to supply, if you also want to write about what effect this particular transition has on the system, you can also provide that by putting a forward slash between your event and, or no, not or, and if it is supplied the guard condition, followed by a slash, something like this. that there is a particular state, there is a particular state here, and there is a transition that is being shown between these two states, and this transition will only take place if this event occurs and this guard condition is true. And what exactly does this signify? It signifies whatever you have written here. So after a slash you can write the effect. By the way, this does not have to be on another line, it could be in continuation. It's just that I've shown it differently so that you can mark it down that this is a different part of this information. And so essentially there are three parts here. Okay, the event is there, the guard condition is there, and the effect is there. So these are all three things are distinct in nature. So there's one more aspect of the state diagrams which we need to discuss, and that are the initial and final states. So you know that whenever you create an object, right, it basically has a life cycle, right? And the life cycle starts by the call to the constructor. So the first thing that happens whenever you create a new object is that the constructor is called. It could be any constructor, it's not necessary that it's the default constructor. It could be parameterized constructor, it could be the copy constructor. But the idea is that the life of an object starts when the constructor is called, and similarly the life of the object ends when the destructor is called. So destructor is called right before the object dies, and the constructor is called right after the object has been created. So what really happens to at these two boundary points of an object, right? So whenever you create an object, it might be provided with some starting values based on the specific scenario. It could be random values, the garbage values that we call, or they could be specific values, specific initial values. It is also possible that you really don't care about what the initial values were, right? Because you have a system where you have a process where whenever you need to use a particular object, you first assign it some values. Okay, a typical example is you create an object and then you take input from the user. So you don't really care whether the initial values were garbage or anything else. You don't care. You are going to assign it an explicit value before it gets used. But in order to show this, right, you have to you have to show that an event has occurred. Okay, what exactly is the event? That the user is typing something and I'm going to put it in the object. So you have to show an event, you have to show a transition. But what is the previous state in this transition? Okay, the next state is the state after which the user input has been stored in the object. But what is the first state, from where you started off? So to do that, you also have the idea of an initial state in the state diagram. So there is a specific symbol. It is basically if a solid circle. So you can use a solid circle as a way to signify that this is the initial state, and from the initial state onwards, these are the events which occur over this particular object. Similarly, when it's the last thing, right, right after you are done with the use of the object, so you're not going to use this object anymore. Okay, so right before the destructor gets called, there is a state, right? There is the final state to which the object goes and then it dies, right? If you also want to depict that within your state diagram, this, just to give everyone an end to end perspective, that this is where the object was created and this is where the object dies. If you want to give the end to end perspective in your state diagram, you can also create a final state. So there is a specific symbol for displaying the final state of an object, and that is what these two symbols look like. This is the initial state symbol and this is the final state. So basically the final state symbol is two concentric circles with the inner one being the filled circle, the outer one being the hollow circle. So and then what I'm showing here is that this is the first event and this is the last event. So last event is basically it could be the destructor being called or whatever it is. The first event could be the constructor being called or something like that, whatever you want. These are not necessary, by the way. Okay, it's not necessary that you show initial and final state. in the state diagram, but sometimes you might require them, right? If you want to show a complete end-to-end life cycle of your object, so in that case you can use these two symbols. Okay, thank you. There are some more things that you have to understand about state diagrams, and that I'm just going to summarize here. Basically, there is really no rule of thumb for picking what objects in your system are you going to use for your state diagrams. You can understand that there might be so many different objects in the system that usually you will only pick a handful, right? But there is really no rule of thumb. Another issue is that sometimes the number of possible states that your object might go through might be too many, so you may only show certain states, the important states, through which your object transitions, right? But all these are specific for your scenario, right? There is really no rule of thumb that I can teach you that this is how you should pick the objects and this is how you should shortlist the states that you want to show in the state diagram. It is for you, right, to decide. You have to figure out what level of detail are you going to put in your documentation. So anyhow, so this is what is the state diagram. State diagrams show the effect of the environment on one single object at a time. So your the class diagrams were going the class diagrams basically showed how the system looks like, okay, when you're designing it. The state diagrams, let us say, you have to prepare one for each object. These state diagrams show in isolation, by the way. So this is something that you have to understand, that here we are not concerned about how the other objects are changing. We are concentrating on one object at a time, and we are showing that based on certain events that may occur, this is how the object will change its state, right? So this is just a summary of what state diagrams do. So now you should understand where this falls in place in that whole picture, right? So where do the class diagrams fall and where do the state diagrams fall? I hope by now you should understand it. There is some homework. One of the more important parts of the homework is that you have to prepare some state diagrams for your projects. Okay, thank you guys, bye.